Hello, everyone. My name is Li Xiaoshuang from Xinjiang Institute of Ecology and Geography, Chinese Academy of Sciences. Today, I am glad to share you the story of a littered desert moss could be a promising pioneer plant for colonizing extraterrestrial environments. This work just published in the high-influence journal The Innovation. Okay, let me see the moss. The Gerbentunggut Desert in northwest China has one of the most concentrated distributions of Centrichia cananervis. The black area in this figure is the Centrichia cananervis crust, it like a banquette covered on the sand, thus playing important roles in biogeochemical cycles and stabilizing the desert surface. This is a close-up view of a biological crust composed of neatly arranged Centrichia cananervis, and we have found for the first time that this small moss, which is less than 1 centimeter tall, has the extreme drought tolerance and resurrecting from the dead. This is an amazing video. We real-timely recorded this rehydration process in the desert use my student's mobile phone. It appearing black when in a completely dry state in the wild after losing more than 99% of their water. Notably, desiccated plants turn green and rapidly recover their photosynthetic capacity within seconds of rehydration. We also record this seconds levels rehydration in the lab with single plant. Centrichia cananervis crusts are predominant in dryland regions, including the Gerbentunggut and Tingher deserts in China and the Mojave Desert in the United States. Centrichia cananervis crusts are also present in mountainous regions of the Pamir, Tibetan, Middle East, Antarctic, and circumpolar regions. The harsh natural habitats gives this moss remarkable tolerance to multiple environmental stress factors. Look at the two pictures between the desert on Earth and Mars. It looks very similar, so we are wondering, can this little moss be a promising pioneer? We tested the tolerance ability under various extreme stress conditions in the lab. Firstly, we reported that this moss showed remarkable desiccation tolerance. It can recover photosynthetic activity within seconds after losing greater than 99% of its cellular water content. It also showed extraordinary freezing tolerance. It can regenerate even after being stored at -80 degrees Celsius for 5 years or in liquid nitrogen for 1 month. Furthermore, possesses super resistance to gamma radiation, with half-lethal dose up to 5,000 grays. After testing the single factor, we further explored the survival of Centrichia cananervis under the simulated conditions of Mars, including the combination of extreme stress factors such as low temperature, low oxygen, and irradiation. This desert moss can survive and maintain vitality in simulated Mars conditions. In addition to dry plants, we also tested completely fresh and laboratory tissue culture protofilament materials in the above extreme stress resistance experiments, and found that young tissues with 100% water content and tissue culture can still tolerate extreme stress and regenerate. The extremotolerant desert moss Centrichia cananervis is one of the toughest organisms on the Earth, which is a promising pioneer plant for Mars colonization and terraforming. We cannot wait to see what might the terraformed Mars looks like. Some work are still ongoing, such as extend the treatment period, to reveal the stress tolerance mechanism, as well as test the performance of this moss grow in Mars simulated soil. In the future, we want to do the space flight experiment, as well as screen and construct artificial symbiotic complexes for space colonization, space exposure, and other tasks. Summary and outlook: we study this unique moss, and focus on the extreme stress tolerance and try to uncover the secret of undead, and not only provide novel insight in plant extreme stress tolerance mechanism, also the survival strategies and wisdom will provide new ideas and applicated in extraterrestrial colonization, super crop breeding as well as new materials designing. So I like to thank the people who contribute to this work and the grant supporter. Thank you for your attention.
Pursue excellence.